All right, I think we're ready. All right, I think so. All right, what we're doing today is mainly Octoprint. So that's a piece of software that will let you remotely talk to your computer where you don't have to use the SD card. And you can monitor it and do things like that also. So we're going to install, this does require a Raspberry Pi of some sort. So I've got an older Pi 3 in this little case. This is a B+, so Model 3 B+, Pi 3 Model B+. So it's an older one, but it will work. They're kind of hard to, or they're not hard, they're expensive to get right now. So you can find them, but the last time I checked, they were pretty expensive, more than they should be. Let's see what they're looking like now. Let's see. Actually, does that kit have one? That's more of a touch screen for that, so that doesn't actually have one. Actually, maybe they are hard to come by. I don't see any for sale. These are all accessories for the Pi. Let's see if there's a Pi 4. Yeah, I don't see any. This one might have one in it, but look at that, $270. That's way more than it should cost. So it might be that unless you have one laying around, that you're not going to be able to do this right now. It looks like they're all, that's just a case. There's a Pi 4, $150. That's way more than it should cost. 160. Yeah. So these are, you can get them, but I would not purchase them at this price unless you just really needed to. But I do have one already that it's not being used, or well, it wasn't being used for anything important. So we will put Octoprint on here so you can see what it does, so that you can try and decide if it's worth tracking down a Pi or not. There could be some other single board computer things that would work, or maybe just at this point it's probably cheaper just to go get an old laptop or an old I don't know, just some old small computer. It doesn't need to do a lot. It just needs to be able to connect to Wi-Fi, otherwise you're still going to be running back and forth to it. Or it needs to be able to maybe Ethernet, something like that, so that you can talk to it. So at this point, it might actually be cheaper to go on eBay and get an older laptop, one of those little mini laptop things. But we're finishing up one print over there on the printer, and I do have some new materials, there it goes, that we can look at before we do Octoprint. So I am going to shut that off. And let's take a little second and look at the things that we've printed here. And just so you can see some new or different materials. So I've got, let's turn off that so you can see them. I've got all of these, all of those. So let's go in order. Well, the one that just came off the printer. This is a high temp PLA. Now these are all printed at relatively thick layers, so they look to me pretty good for the layer thickness. This is a 0.6 nozzle, and the layer thickness is like I think it's either 0.4 or it's at least 0.3. I don't remember what I set it to. I'm using the same file on all of these. The only thing I change is the printing temperature if they need it. Some of these had to be printed a little bit hotter than others. So this is a high temp PLA. So you'll find this, I don't think this particular one you can find anymore, but there are plenty of high temp PLAs. HT PLA is what they'll look like in the name usually. So the thing with these is that they do print a little bit hotter, so 210 or to 230, somewhere in that range. But what you do with them is that they can be annealed. So that means that you can take and heat them 10 minutes or so at maybe 200-ish degrees Fahrenheit, not Celsius. And they will recrystallize. So they will become a little bit stronger, a little bit more heat resistant. So for instance, if I were to anneal this piece at 200 degrees Fahrenheit for 10 minutes or so, then instead of having a heat deflection, you know, a glass transition temperature somewhere around 60 degrees Celsius, I'm mixing units there, but that's just what I'm doing. Then it would be around 85 degrees Celsius for the glass transition temperature. It should be a little bit stronger too, a little bit more tough. So maybe not, I don't know if its tensile strength would necessarily increase, but its toughness would. So we could have a little bit stronger part, a little bit more heat resistance. The downside is that annealing process can deform it. So whenever you want to anneal, this is just a vase mode print, so there's no infill. But whenever you want to anneal a part like this, it pretty much has to be a solid part, or you're going to get some unpredictable shrinking of the part. You'll still get some shrinking probably, but at least if it's more geometric, you know, like a rectangle or something like that, and it's solid, then you can better predict what it's going to do. That might be a good thing for us to do, is do some actual test on annealing some of these materials. I think you can probably anneal any material. Some of them are just made to be annealed. So that's this guy. This one, let's see, I think it's this one. This one is a polyester, a PLA polyester blend. So this one did have to print really hot. I printed it at 240. I think it can print around 230, which is, you know, the upper limit. If you don't, if you haven't changed anything on your Ender 3, a stock Ender 3, upper limit's around 235 or so on what it'll print. This one's actually a pearl. I don't know if that picks up on camera very well. It's probably a little bit out of focus. I don't know if I can make it focus on the right part. It's a little bit, well. But in person, it does have a little bit of a pearl finish to it, I can tell. And again, it would probably look a little better if it had thinner layer lines. But this is a polyester, so that's going to make it a little bit more, or more ductile, less brittle than a typical PLA. PLA itself is a little bit on the brittle side, so this will, especially for these plastics, so this will increase it, again, increase its toughness. This one you don't anneal. I guess you could, maybe, I don't know what the polyester blend would do, but it's a lot less brittle. So this is PLA polyester with a pearl finish in it. Let's see what we got here. Oh, this one. This one, let's see, we gotta have our little flashlight. This one is a UV sensitive one. So it's kind of transparent-ish, but you shine a UV light on it and it becomes purple. Or, well, it color changes. This particular one changes to purple. So it can be used as just a novelty thing, or maybe a UV detector even, if you wanted to know if there was UV light in a certain place. It'll color change under UV light. So that was kind of neat. This is from Hello 3D. It prints just like PLA though, so no special thing. It actually is PLA with light change properties. Then we've got, oh, this one is maybe my favorite one. This is an elixir filament from Polyalchemy. Now they don't, as far as I know, exist and make filament anymore. I believe the printed solid people have their filament now. Maybe they bought them. I don't know exactly what they did. But there are other silk filaments. So this is the elixir, which I don't think, other than maybe some random surplus somewhere that's still in stock, you can't get elixir anymore, but you can get silk filaments. There's all sorts of silk filaments, and they are, this is kind of what they do. They're very shiny, very shiny, and I like them a lot. I really like the elixir. I don't know what happened to their company, that they weren't able to keep making their filament, but I don't think you can buy Polyalchemy elixir, but you can buy other brands silk filament, and they look similar to this. So, and it's just PLA, just prints like PLA. Here's a color fab stone. This one I kind of need to try and get it to be a little closer here. Let's see. We can. Now again, it's got the thicker layer lines because of the nozzle I'm using, and I probably, this one would definitely benefit from printing thinner layer lines, I believe. And it looks like it might have been over extruded a little bit. I'm looking at it on camera, and it's not nearly as good as what it looks like in person. It really does look very stone-like. It doesn't have any actual stone in it, so it's not a stone feel. It doesn't have stone powder or anything. It's just made to look like that. It actually has a little bit of a gritty feel also. And this is from Color Fab. Again, it's just PLA. It prints just like PLA. All of these, except probably the Elixir one, probably need a hardened nozzle. The high temperature one probably doesn't. It's just higher temperature. But they probably need a hardened nozzle. This one definitely felt like it would be abrasive. Just holding the filament felt like it would be abrasive. And let's see what we've got here. This one's 3D Fuel. This is made from, let's see, what's it made from? Well, it just says the leftovers from byproducts from the beer making process. So I'm not sure exactly which byproducts, but it is made from that process, the leftovers from that process. It's got a cool finish on it. The filament came out very nice. This is it. It's the 3D Fuel. I haven't looked to see if you can still get them or not. Some of these are older and you can't get them. This next one is probably my favorite one though, for real. Well, you know, I do like that one. But this one is, it looks just ordinary gray. But this is actually a steel field. So it's PLA. It prints just like PLA. A little bit hotter, maybe 215 instead of 205 or whatever. I think I printed it at 215. Definitely abrasive. Probably do need the larger diameter nozzle, but it is actually filled with ground steel particles. So like if we were to, let's see if we can get this on here. We were to weigh this guy. So it's crooked, but that's 10 grams. Weigh this guy, twice as much, 20 grams, 19 grams. So it is definitely heavier. Now, and these are thin single wall vase mode prints, so they're not heavy to begin with, but it's twice as heavy, so twice as dense as regular PLA. And, oops, shaking the camera around. It says, I haven't tried this, but it says that it can be burnished and, you know, kind of sanded a little bit. We're about to try that and see what actually happens with it. I don't know. It doesn't necessarily add any strength because you're not actually centering the metal particles. I do have, let's bring this up real quick. I did take a microscopic view of the filament. So let's look at that. So not that one, that one. Here, this red is a regular piece of just PLA red filament. This is it, the top one. So you can definitely see that it is an abrasive. It looks like something you would sand with, right? So it is definitely abrasive, definitely filled with steel particles, and it definitely does weigh more. It costs a lot more. It costs like 5 times the cost of PLA. This particular brand is Protopasta, which you can still get the stuff, but it's just expensive. It doesn't print any different, maybe a little bit hotter, 210 or 15 again. But it's definitely abrasive, and it works a lot better with at least a 0.6 millimeter nozzle. Otherwise, you're probably going to clog the nozzle if you try to print it on a 0.4. Like I was saying, it doesn't actually make it any stronger necessarily. Maybe it increases the compressive strength. Not sure. But tensile strength is all dependent on the PLA and everything. So you're not centering metal. It's more ornamental. Now, there are some, I'll pull up a thing in a minute here where you can make metal FDM parts, but it's a whole process. So let's I've got some steel wool, and let's just see if that does anything to it. It did smooth it a little bit. It's a little bit rough texture. Let's see, I've got some other things here. So yeah, you can do a little bit of burnishing, you know, hit the high spots and make it look a little worn. It's kind of a neat. So yeah, you can kind of treat it like that, make it look distressed or whatever. That's an interesting thing. That it looks like it's doable. It's kind of neat. and it does sort of act like metal. I don't know if you can do other treatments like the patinas and things like that. I didn't try any of that. So that's kind of, maybe I won't do that right now, but I'll go in and finish this guy up sometime and see what it looks like. So those are just some different filaments that I have samples of. That some of them are interesting, some of them are just plain. Some of them have potential that we didn't explore here, like the ones you can anneal. I don't have a good way to anneal it right here, so we'll have to work on that later. The other thing I've got is kind of off the screen here. This is what we'll start trying. So this is a extruder, but not for plastic. So it's for, well, this particular one is sold for chocolate, actually. So paste, materials that can be extruded like toothpaste and not more like plastic. So I've mounted it, haven't finished installing it. I've got to obviously redo the limit switch type situation so it knows where the Z direction is. So we'll have to work on that a little bit. But we'll see how that goes. I've never used that before, never used any of those things before. I don't have super high hopes for it. It seems a little bit finicky on getting the chocolate or whatever you're printing to actually cool in place. But we'll try it out. It's actually probably a little bit warm out here for doing this because it's going to need to cool even more than PLA or something like that would cool. In fact, they say people use like air conditioners on them or ice packs all around it to cool the ambient air to get it to cool in place. But we'll see. That's coming for later. We're over here on, that's not the one I'm going to add Octoprint. We're going to add it to this one that we've been using. That's the older, actually that's probably last year's printer. I don't know which one it is. But this is the one we've been using. I do have this that we're going to add. This is just a little light bar. It plugs into the power source right there. So it's just going to plug in back in the back, intercept the power going to the motherboard, and power this little light bar. I'm going to mount it if I can get to it. Well, I can't even see the top of this printer. I can't get it. Well, we'll have to tilt. We're going to mount it right up there, like that, so that we can get a little more light on our prints. Has nothing to do with Octoprint though. Let's go to Octoprint. All right, so I was going to show you the steel thing first. Let's look at that, and then we'll do Octoprint. The virtual foundry. This is, let's see, are these the starter kits? Well, no, there's that filament, not the filament that we just printed with. This is the virtual foundry stuff. So the idea here is that you will print FDM parts like you would normally. They are much higher content metals. So let's see which ones I can get here. I've got, might have to zoom out a little bit. There we go. Copper. Let's see. These are all the centering parts. There's aluminum, high carbon iron, stainless steel, bronze, more stainless steels. There's copper. I think we're repeating now. These look like the same things. All right. So these are obviously way more expensive. This is a half kilogram for $142. Half kilogram for $100. So way more expensive than what you've been paying for PLA. The difference is that these are, almost all metal. They do have some binder PLA that holds them together that you can print them. They even come, or they don't come with, but there's this add-on, this little guy, filler warmer that keeps them pliable enough that they can, being spooled into a coil and all that kind of stuff and still print. They're very brittle. But what you do is you print your part, and then there's one of two options. They have these options here where you've got the whole centering kit. Now you need a kiln, like this guy or something, or access to a kiln, basically a high temperature heater. And you print your part, pack it, or clean it up. So that's called the green part. So you do whatever to clean it up. Maybe you sand it or polish or whatever you're going to do to kind of get the surface finish right. You pack it in your ballast. This kind of, well, where'd they go? Sorry, I'm scrolling everywhere. There they go. You pack them in your ballast. I think they have different ones depending on what material you are sintering. And then you've got your sintering carbon on top of the ballast, so it's all in a little crucible. Put it in your oven for a lengthy amount of time, probably like 12, 18 hours, I don't know. There's a whole cycle for sintering it. And then when you're done, the part has actually sintered or melted the metal particles together and removed most of the PLA stuff. So it does shrink, you know, depending on the material, it shrinks 10 to 20% in size. So it will, you have to plan for that amount of shrinkage. Now you have to do that with casting in general. So if you're casting aluminum, you have to plan for the aluminum is going to shrink. Or if you're injection molding plastic, you're going to have to plan for that shrink in the cooling process. So that's a thing you have to plan for in a lot of different processes. So that's kind of normal that you have to plan for that. But you end up with a part that is 85 to 90% metal in the end. So it's not 100% metal, but you actually end up with actual metal parts. I would think of these as parts that you would probably not use the part right out of the sintering process, but you would use them as a blank that you would go and machine the necessary surfaces on, you know, the mating surfaces on. And you could have a 3D printed metal part. I've never done this because it's a whole process. There used to be, and let's see if it still exists. Virtual Foundry. There used to be a process where you could send your green part, your just printed part, back to the Virtual Foundry, and they would go in and do the sintering for you. I don't know if they still do that or not. I'm trying to see. Oh, there's some special order: titanium, cobalt, iron, nickel. I'm not seeing if they still have their process where they will do the sintering for you or not, because there used to be like a ticket here. It was like $50 for a ticket to actually have them do the sintering, which I don't see on here on their website anymore. I'm not seeing that, so that may not be an option any longer. So you have to figure out how you're going to. Oh no, that's a sample. You have to figure out your sintering process, but it's probably something I want to do to see out how well it does work, but it's kind of expensive to just try for the fun of it. So I'll look and see if I can find where they will do the sintering. Then it wouldn't be so bad, but I don't really want to buy a whole kiln and everything just to try something. So that's something for later, but it does exist. So if you're thinking you must do a metal part, but you want to 3D print it in FDM process, so you want to do it yourself, then this is a way to get that done. Typically what I would say you would do is, if you needed a metal part printed, is there are plenty of online printing services, Xometry, Shapeways, where you load up your CAD file and they will do the part on an actual direct metal laser, laser sintering, whatever kind of printer they have, and print your metal part for you. And that part in that process is usually in the high 90% metal when you're done with it. So this is just an option that I never tried, but I know it exists. All right, enough of that. Octoprint. So octoprint.org, and you actually don't need anything from this website, although I think they do have like the instructions for how to install it, which I was kind of looking for so that I could remember them. Let's see. Let's go to maybe in the download page. I don't actually want to download this. There it is, installing Octopi. All right, so I'm actually going to do this the easy way. So this Raspberry Pi imager, if you haven't seen that before, it is a separate thing, this thing. And raspberrypi.com/software is the, let's put the web address on the screen. There you go. That's where this is located. And there is a imager that it doesn't just do Octoprint. It does all sorts of things. But it will go in and we'll look at it in a second. But I downloaded it here a while back. And it will do most of the installation of our Octoprint stuff for us. So I've already downloaded this thing previously, and here it is running. Let's close that. Go over here. So here it is running. And what you do is you choose the operating system. Oh, I need to get a SD card. So they all run on these little micro SD cards. Can't figure out where the camera is. There it is. So I'm going to put this guy in here. There's probably already Octoprint on this one. This is a 8 GB card. Yeah, 8 GB card. And we're just going to overwrite whatever. Yeah, it's already got something on it, but we'll overwrite it. All right. So here are all the different things I can do with this. I've got, you know, emulation for retro gaming. I've got general purpose operating systems. These are the ones that are more like Linux type things. I've got media players. I want to do a home media setup. I've got, oh, that's one I just already clicked on. Yeah. There's the 3D printing one. There's home automation, all sorts of different things. But I want the three. So this was in the other specific purpose OS. So 3D printing. And then even in 3D printing, I've got several things. I've got the clipper ones in here now. Those weren't there before the last time I did this. That will be interesting. That I do want to show you Clipper. It's another one of those that's going to need a single board computer like the Raspberry Pi. So that might be a problem, but we'll just put it on this same one that we're using this on. But right now we're doing Octopi. And we will do the last stable one. We don't need the nightly build. We'll do the last stable one. Now there is, I always forget this key combination. Oh, there we go. Now did it do that? All right, so if I click this, hold on. All right, so no, it's, no, nope. All right, so Control-Shift-X. So not sure why that's their shortcut key, but Control-Shift-X. I can set this to always use or for this session only, and I can go in and you can go ahead and set your username and password for the Pi. The default is Pi and Raspberry on a Pi. I can set what I want. I can go ahead and configure my wireless. It looks like it already remembered mine. I don't know if that's the right password or not. I'll have to hope it is. I won't show you what it is. But you can set the time zone. I don't know if I want it to play a sound when it's finished. But so these are kind of the advanced options. I don't know why they don't just have a button with advanced options, but if you do the Control-Shift-X shortcut key on here, it will bring this up and you can set all of these kind of things. So I think we'll leave this the way it is. We'll leave it the way it is. And we will click that. Choose where, you have to be careful here. You do not want this to end up on your, like overriding your hard drive or something. It typically does not even show you options for C: or D or anything like that. It only shows the USB devices. But make sure that you have selected the correct one here because it's going to completely format, erase whatever's on the storage, in this case our SD card, and override it with whatever operating system you selected, which is Octopi. So I'm going to do that. And then we'll click, hey, maybe there's, no, okay. So the last time I used this, I don't think it, maybe I just totally missed it, but there is the button that will do the Control-Shift-X thing that's on the screen now. The last time I used it, it was an older version though, so I really don't think that was there, but maybe it was, I just never saw it. So we're gonna write, and it's giving me the warning that it's going to overwrite everything on that disk. So do I really want to do that? I do. And now it will take a few minutes. I probably should have started this and then we should have looked at the filament. I didn't think about that. Now it did off on the other side of the screen here, it did open up a window that said basically that SD card had been accessed. Do you want to open it or anything? Just cancel that, because it's going to ask you maybe to format it or whatever. That's not the imager doing that. That's Windows doing that. So if you get any pop-ups about the file manager stuff, cancel, close those, and let the imager do all of the work here. So you can see it's writing. It's at 3% now. What can we do in the meantime? Oh, we can install our light. Let's do that. See if I can figure out how to get where you can kind of see or what we're doing up here. It's way at the top of the printer, so you can kind of see it up there. So we're just going to mount it. It uses these little guys that are sliding. They can slide in from the end or they can twist in. And they're slotted on this end, so we just need to get them in there and tighten it down. So I'll slide this guy in there. Oh, and actually we'll slide both of them all the way through. You don't have to slide them through. They will go in and twist in. And then we're just going to put our light here. See that? Oh, see, so sometimes they end up turning that way and they don't actually catch in there. So you have to be a little bit careful with that. All right, there we go. Right, it always seems to me, if you loosen them to where the little T-nut part is just barely hanging on there and you quickly twist it, that it will rotate in place and catch. The only other thing I have to do is I have to go back here, so now we don't have to be way up at the top anymore. And let's see if we can see it. Oh, I can't do it on this one. Oops. I'll have to put it on a different printer. This one, I forgot that, look here. So this one, there should be, on a new printer, there would be one of these guys right here that I could plug it into. This is one where, and this happens occasionally, those XTC 60, whatever, I have to look it up. Let me see. I think it's XTC 60. Let's see. Maybe we can find it on Amazon. There we go. So these little connectors right here, the ones on the far left over there, those are what should be there right here, but you'll see that mine are soldered together. What can happen occasionally, if the printer did not have a good connection on those, like they did a bad solder job, or if they crimped them, they didn't crimp them well, then that little bit of a loose connection will create a higher resistance because it's not making a good connection. So the higher resistance will cause the current to have to be larger to get the same amount through there. And that increase in current will create extra heat, which will melt those connectors. So every now and then you should probably go back here and look and see if the little yellow connectors are turning brown, like they're looking like they're melting. This one did. That's probably the biggest hazard on these printers. I mean, you would think the nozzle would be, which it could be if you don't have thermal runaway protections in place for it. It could be that the nozzle would be the worst case, but this is usually the thing that there's no protection against. It's just going to deliver power. This is coming from your power supply over to your board over here. And this printer was one of the ones that it didn't melt or create a fire or anything, but it was looking melted a little bit, and that was a little worrisome to me. So I cut the things out and just soldered it directly, so I can't actually unplug it and plug this guy in there. So what you would normally do is unplug the other one, patch this one in, and then you have power for your light. So I guess I can't actually add the light bar to this printer. I can add the light bar, I just can't turn it on. So that's just what we'll have to do on that one. We're at 33% on our Octoprint over here. I guess we can go ahead and do our, there's not a whole lot on the hooking up the Pi. This is just a 3D printed case. There's all sorts of cases out there. I'll take it out of the case just so we can see what's going on here. But you probably do want a case for these things because they are completely exposed. You know, there's nothing there keeping you from shorting them out if you lay them on the something metal or conductive. So that's why it's in a little case. But basically all I'm going to need to do is turn it on. There's no on-off switch. You just power it right there with something like this. If I plug this in, it's going to come on, and it's going to not do anything because it doesn't have an SD card in there. The operating system, everything is going to be stored on that SD card that we're writing, and we will oh, lost our web browser. We'll use this one. So it's going to be stored on this SD card, and that's what will boot it up. The only other thing I'll need to do is I need a USB to plug in from, oops, covered it up. Plug in from here to one of our USB ports. So I have one. Is this it? I think this is it. So we'll do that. Go ahead and do that. Now, this one's way longer than it needs to be, but I guess it'll let you remotely mount the Raspberry Pi somewhere. Now, you do have to make sure that this USB cable that you're using here is a data cable and not just a charging cable, because if it's just a charging cable, then it will turn on the printer, like the screen will come on, but it doesn't deliver enough power to actually do anything. So it can't turn on any heaters. It probably can't even do any stepper motors. It'll probably do the BL Touch, or well, in this case, the CR Touch startup routine, maybe. And it'll look like things are working, but it won't do anything because there's no data flowing. It's only power. So make sure that you're actually using a data USB cable and not a charging USB cable. So that's all there is to hooking it up. There are some little power converters where you can go in and use the power from the printer to power this thing, versus what I've got is this. I've just got one of these little guys with this on the end, and it will turn on our, or it will activate power our Raspberry Pi whenever we want that to happen. I don't want to do that until I actually have something on the SD card, which we're not there yet. We're at 55%. If you didn't, so back over here, if you didn't input your wireless information, your router name and password, if you didn't input that, then you would need to go in, and I believe, let's see, oh, did I close all of those? I might have closed them all. There we go. I believe it tells you how to do this. Yeah, the alternative initial setup. This is if you're not if you didn't go in and put in your Raspberry Pi, well, not the Raspberry Pi password, your router password. If you didn't do that, your Wi-Fi password, then you would need to follow this setup where you go in and actually edit the files and do all that yourself, which is not that difficult. You would just have to do that. We will still need to do some of that kind of stuff just to be able to talk to the Raspberry Pi. We may not have to edit any of the files on the SD card though. We'll see. Let's see, what else are we waiting on? 60%, so we're still waiting on it to install. I guess I could have gone ahead and installed it beforehand, but I don't know, I didn't. So we'll do it now. There's the Control-Shift-X thing, which they do have the button for now, which maybe was there all along and I never saw it. I don't know. Oh, I will say this. If you are at a place where you have to input a username and password, so you're at work or someplace where the login is not just a password. So if you're at home and you've got your Wi-Fi router and you just put in a password to do that, then this will work fine. If you are at a place where you have to put a username and password, that is a whole nother issue. It's difficult to do. Well, first of all, what you would have to do is you'd have to go into this alternative initial setup. The problem is that when you go to talk to the Raspberry Pi, so find it on your network, it's going to get a random IP address. That's not so bad to find when you're at home and there's 10 things on there maybe at most, and you can sort through them. But if you're at an industrial network and it's got this random IP address that could be anything on the whole network, that gets a little bit hard to find. So I have done it before. There's two ways to do it. One is where, well, there's kind of three ways to do it. One, probably the easiest way is just go to your room, office, whatever, and if your network will let you, then set up a Wi-Fi router of your own and connect to that. So that's probably the easiest way. Some business networks won't let that happen. They see a random wireless network running off of their network and they'll shut it down. So if you can't do that, the next easiest thing is get a permanent IP, a static IP address assigned to that particular Raspberry Pi. So they can connect Ethernet. So there's a little Ethernet port over here. So you could connect it to Ethernet and give it a static IP address. You can even do where it has a Wi-Fi static IP address. So you'd have to work with your computing center to do that probably. And then once you have this static IP address, then it can go in and you can just find it every time because it's always going to have the same address. If it doesn't, if there's no way that you can get it to have work on your kind of little subnet local thing with your own Wi-Fi router, and you can't get a static IP address for it, I have done this before, and I don't even remember all the steps to do it. But you can write a script on here that when it boots up, it goes, finds its IP address, and then either I think I had to do an email. It emails you its IP address. So basically, it's got a little wake-up routine that whenever you turn it on, it goes, gets its IP address. Once it has its IP address for the day or until the next power cycle, then it emails that to you, and you get this little email that, hey, today my IP address is whatever. Then you can connect to it. That's the only way the only three ways I've ever figured out how to deal with this on a like a enterprise type network where you have to log in with a username and password. So let's see where we're at on our 73%. So we've got to find a few more things to talk about while it does its last little bit here. I guess we can look at Octoprint, kind of what we're going to get when it does install, because there's no guarantee that we're going to get this. It's going to boot right up. Hopefully it will, but there's no guarantee. So the idea will be kind of this screen right here, where I will log into anything on the same network. That's the issue with the IP address thing, is I need to be able to get to the IP address of this Raspberry Pi. So that's the thing. So I need to be able to log into that. So if I'm at home on my own Wi-Fi, then that's easy to do. If I'm remote trying to log into it, that's not so easy to do. But anyway, assuming I can get to that IP address, I'll get this screen on an iPad or a PC or wherever. I won't necessarily get the picture of it here. What the picture is, you've got USB ports. I'm using one of them to connect to the printer, but I've got 3 others. So plus there are Raspberry Pi cameras that plug in here, right there. So if I have one of those, if I have a USB webcam or the Raspberry Pi camera, then I can actually set that camera up and see what it sees. I can point it at the printer and visually watch the printer from wherever I am logged into it at. By default, I didn't plug anything in here, so we're not going to have that image, but I think I do have a webcam right here. Let's see. Yeah. So we could do that. It's got a super long cable on it, but that'll be all right. Get the right cable. Now there are some setup that you can do to make your webcam work better, but we're just gonna plug this in right here. So all I did is now I've got 2 things plugged into the Raspberry Pi. So we'll set it somewhere over there. It's kind of just setting out of the way right now. And what I'll be able to do is I can load G-code from that source, the iPad or my computer or whatever I'm looking at. I can load some G-code. I usually just use my computer, hit print, and it will send all of that to the printer and print. It will be dependent on a couple of things though. So if you have a slower, like you got a Raspberry Pi, but it's like a Raspberry Pi 2 or a 0 or something like that, and it just doesn't have the processing power, then it will potentially have surface defects in your print because it can't send enough data fast enough. So you do want the 3B plus or higher. They probably have a recommendation. Let's see. Not on the donate page, on the download page. Here they go. So 3B looks like their minimum recommended hardware. I'm using the B plus or a 4B or a 02. I haven't used the 02. I wonder if the 02s are available. But this is what it says: expect print artifacts and long loading times with other, so like the 2s or anything less than these. Pi 0 and 0W, not the 02, are not recommended explicitly, since you will not have a good experience. Basically, you can get it installed and everything. All this stuff that we're doing now will work, but it's going to run very poorly. So be sure that you're at least a 3B, which works okay, and then the more processing power, the better it's going to do. If you're going to get, if you're able to get a Raspberry Pi, I think the 4B will be the best option if you can get it, because that's going to let you do more things later down the road better. So Octoprint mainly just kind of does printing stuff, but there are other things, particularly Clipper, that will do a whole lot more. Oh, it looks like we might be done. All right. So here's one of the prop-ups. All right, so be aware of this. I just finished, and I got this. Do not click on this. This is anytime you put the Linux-based, now it's got this Octoprint running Linux and all that kind of stuff on it. you're going to get this pop up. Do not format it unless you want to erase everything. So cancel that. Cancel all of them. They actually popped up 2 or 3 different times. And here we go. Octopi, the stable release, has been written to here. I can now remove it. All right. So we're going to take, or actually we're going to take the little guy out of there. Put it in over here, and I'll just do this. Be careful. These things are kind of fragile, particularly like if I'm sliding it into this case right here. There's a good chance that you jam it against something and break the SD card, or pull the SD plug off of the board. All of those are bad things. All right, so I'm going to turn on the, no, actually I'm going to turn this guy on first. So all you get is a little light that comes on. You can kind of see it right there. Now, that may not, now I actually need to check. See, it powered on the printer. Actually, I should check here the right order. Let's see. Yeah, it doesn't like that. That's fine. Because it's got other firmware on there, right? So all right, so let's, all right, we'll turn on power. That's this thing over here telling me I don't have enough power. All right, so now we need to find our Pi's IP address. So the easiest way to do that is to log into your own router. So I'm assuming you're on Wi-Fi at home. So you log into that router, which is usually 192.168.1.1. So that's, I'll say that again, 192. So you go to a web browser, right? So let's see if we can get a web browser up here. You go to a web browser up here and just 192.168.1.1 and log into that. That'll usually be your router's like home address. So I don't know that I want to like broadcast all of my stuff here, so I will do this part off the screen. I'll just tell you what I'm doing. So then you're in your router's homepage. Somewhere in one of those things, it should have an attached devices button or tab. And what that is all of the devices, your iPad, your computer, your now hopefully your Octoprint, that are attached to that router. And so you can go in and try to find the one. All right, I see one here that looks like it might be it, but I do have others. I do have others that are also connected, also running Octopi. So I'm not sure that this is it or not, but we'll find out. So let's try. This. Okay. I don't remember it's having a, this is not it. Let's refresh our list. That was one, but it was not that one. It was one that was already connected. So, well, a couple of things might have happened. One of them could be that this Pi did not get connected to my router. So that's possible. Or it could be that I'm just not seeing the right thing. Let's refresh our list over here and see if a new one pops up. Because it could take it's got to go through its own boot up cycle, and it has to actually get connected to my network. I don't see it connecting. All right, let's let's check. All right, so what I'm going to do is I'm going to turn it off, which means unplug it. And I'm going to take the SD card and load it onto my computer. Okay. Now, let me bring these over so you can I move them? So you're going to get, oh, there it is right there. You're going to get this kind of thing. You're going to get this kind of warning every time you plug that SD card into your computer. So don't ever format it unless that's what you really want to do. So what I'll get is this it? I think this is it. All right, I don't want to cancel that. I got other pop-ups that are also there. All right, so I think it's, ooh, there's two of them now. Usually this Wpa Supplicant file here is the one that you need to edit. I'm going to again turn this off so that if that's not the right thing, I don't give away all my password stuff. Yeah, so that did not put my password into the system. Let me check the other one because there's Octopi network. Okay, no, okay, that's now. All right, so let me show you this. I can show you this because there's nothing actually here. So this is the Wpa Supplicant file. So for whatever reason, I thought I told it to put my home password in here, but it didn't. So maybe I didn't tell it the right way. But right here, this is it. I've opened the Wpa Supplicant.txt in Notepad or Notepad++. And here, this should be your network information. So what I need to do is uncomment these. So uncomment these. So they're actually, those hashtags are actually comment markers so that it's not being read. So here you would put your network name. And here you would put your password. Those are obviously not my network name and password, so we have to put the right ones in. So I'm going to hide that, and I think this is all right. Something like that. Save it. Back on the SD card. I never removed it from the SD card. Save it there. Let's eject that SD card. If you don't eject these, like if you don't actually go through the, let's see, I think it's this set. Right click, eject, then they stand a good chance of getting corrupted, and that's never good. And let's go back over here, plug it in. And turn it on. Now they do make some of these USB cords that have a button on them. I just don't have one here, so that you don't have to unplug and plug. It actually has a switch, but I don't have one of those with me. So we'll do this. All right, so it's back on. The little green light is flashing. That's saying that it's trying to do something. There we go. It's doing some network stuff now. It's off the screen. But you can kind of see the green lights flashing right there. That's it communicating on the network. So now, I'm going to go back to my router, check for connected devices. I have to refresh that page to get it to update it. Yes, now I have more connected devices. So let's see what we've got now. But I have more connected devices, but I don't see what I'm looking for. Let me give it another. Refresh it again. Let's see. There we go. All right, we have it connected. So it just took a while for it to actually get into the table and listed. So we have its IP address. So, and they'll all look like this. They'll all have 192.168.1, and then the dot something will be its IP. This one came in as 3. Oh, did it come in as 3? Maybe I read it wrong. Let's see. Said it came in as 1.3, but oh, okay, here we go. All right, so once you get the right address, now on some computers you can, it even says here, you can do octopi.local. That never works on my PCs. That usually is going to work if you're running a different operating system than a PC, but so I usually have to go and find the actual IP address that it got assigned. That's why it's so difficult if you can't see those IP addresses on the network. Like if it gets a random IP address every time it logs in, and there are, 200 items on that part of the network, then how are you going to find that? So here's where it starts at. So we'll just go through the startup thing. I do not want to restore from a backup. Here is now mandatory. So this is so that people can't log into your Raspberry Pi and control your printer. So we'll use my name as my username. Passwords, I don't know. Maybe that will work. So there we go. We have a password. I don't want to update it because I don't know what that goes with. So we will just okay, so this little warning, under voltage is possibly a problem, but usually not. But what it means is that the power supply, I'm using just a wall adapter thing, may not be putting out quite enough voltage to supply the Raspberry Pi. I've never actually had a problem, but make sure your power supply is actually good enough to power the Raspberry Pi. This one should actually be fine because it came with the Raspberry Pi, but I don't know, it gives that warning. So this is it's checking to make sure that it's still online. It doesn't need to do this, but you can let it. I'll enable it. It's fine. Anonymous usage tracking, if you want it to send data in for development, the Octoprint. I don't want to do that, so we're gonna not do that one. You can, it doesn't. Blacklist, so there you can get all sorts of plugins for this. We're not even going to look at any of those today, I don't think, but there are all sorts of plugins. Some of them could be bad or malicious, so they have been blacklisted. So I'm going to enable that. So I don't want to even look at the ones that have been blacklisted. Here's your general printer profile. It is rectangular. It has a heated bed. Origins in the lower left. The print volume for this printer is actually, I think they're 220. Let's get out our little ruler. Yeah, 220. I think it's actually, whoops, 225. We'll do 220 just to give a little margin. And the height, I think, is actually more than that, but I'm probably not going to print anything. We'll do 250. Axes. These, if I need to change any of my acceleration speeds, these look fine. I'm actually running a 0.6 millimeter nozzle, so we'll change that. I only have one extruder. That's fine. All right. It gives you some warning about don't leave it unattended, because what they're trying to guard against is you're probably going to go now put the printer off somewhere and send files to it without even being at the printer. So they're making a warning that you're leaving your printer off on its own somewhere. So be careful with that. And we will finish up. And already there's an update. I'm going to ignore that for now. Okay, let's check. If we look now, this is the Raspberry Pi reading the temperature of the printer and sending it wirelessly over the network to my computer, which is looking at that data. We are not connected yet though, so nothing's. Let's try and connect. Okay, we're connected now. We're actually looking at live data. There's nothing there though. There's the current temperature, 26 and 27, which is also what the printer is reporting on its screen, which makes sense because that's where it's getting the data. If I go to control, there's the view of the webcam. So you could mount this somewhere to look at your printer, right? It does look like it needs to, there it goes, it focused. So you could mount that and look at your printer somewhere. We'll just kind of set it over here. There we go, we can kind of see our printer. You can home. So you can hear it, you can't see it move. There you can go, you can see it moving. This is on the webcam. So I'm not doing anything at the printer, I'm actually at my PC. Uh-oh, got an error. But it doesn't tell me what that error might be. I did get an error. Firmware reported an error. And I disconnected. Let's see what our error was. Homing failed. It shouldn't have failed. I'm not sure. Oh, this could be a problem with the particular firmware that it's running, because I have noticed that when it goes to home, it gives a soft limit error. Like it's fine, it prints fine, and on the screen on the printer it does bring up a in-stopped hit, I think, error, but the printer carries on fine. But maybe Octoprint is looking and seeing that it saw an error, and it is that's all it's going to do. So I wonder if it's going to continually. I may have to figure out a a fix for that. Let's see maybe if I turn. I don't know what's going to be the best way to. I think I may have to shut it down and back on. Now, shutting it down does not actually reset it, because it's still being powered by the Raspberry Pi. So I have to turn everything off. I have to unplug here and turn here off to actually get the printer to go off. So we'll give it another go. It might be a thing I need to fix, and I'll have to look up the fix for that, because I don't know what it is offhand. But I think it's because I do get a homing error, and I've just been ignoring it because it's been fine, but Octoprint may not be fine with that error. So now the potential problem is I restarted our Pi, right? Can't get everything on the screen at once. I restarted our Pi. So it could get a new IP address. Now typically on your own network, it does not do that. It gets the same IP address, but it could have a different IP address. I'm going to restart the Octoprint server. Oops, you didn't see that. I'm restarting, so I went up here to restart Octoprint. So it's still starting up apparently. It looks like we're about out of time, so we may not get to actually do any more than that until I get the error corrected on the printer. But we'll see what it does. All right, let's connect. All right, let's see. You can also send G-code right here. So I can do a G28 from here. And it homed. It's trying to, I guess we could look at the thing. So we're kind of off in the, there we go, it's homing. So it homed okay that time, so no errors. So there was an error, which doesn't seem like it bothered here. Looks like it's fine here. So you can actually do all your G-code commands like we did in Pronterface. You can do them right here in this little line right here. I can do a, I don't know, a M105. Oh wait, that doesn't do anything, does it? What is the one that, or it doesn't do anything that it's not already doing? What, 503? Is that the one that reports all the data? Oh no, that's the filament thing. What's the one? Well, I'll have to look it up. But what I could do now is, I don't have a currently one ready, but well, here's one. I could drag, this is a TPU base version. I still haven't gotten that TPU stuff to print. I think it's too much moisture in it. But you could just drag a piece of, no, that's an actual 3D object. You can slice over here. I don't actually want to do that. I want to, here's something that's STL file. Oh yeah, I don't want an STL file. I want a G-code file. Do I have any? I don't have a G-code file on my computer easy to get to apparently. Let me see if I can find one quick. Got to be something in here that's already sliced. There we go. We got something. All right, XY calibration cube. So I just uploaded that, and now I can hit this print button, and assuming it had the right settings, you know, the right material and everything for what's loaded in there, it would go and print it. So you would just hit load and print. You could watch it print. You could watch it, you know, the actual G-code visualization of where it's at on the bed at any point. You could watch the G-code scrolling by. I don't have the time lapse set up, but you do have a way to, if you have a camera connected to it, create a little time lapse of the print as it happens. Octolapse is better for that than this built-in time lapse. That's one of the plugins. All of these plugins you can find over in here. There are plenty of plugin manager. You can find all sorts of plugins. Now that we've got it running, we will look at some of the more popular plugins and actually print something, but we're like 1 minute left, so